popular content should be stored in the base station and others should be stored in the cloud. So this will basically reduce your latency of reduction. And how will do it? Machine learning can able to decide which is called popular content, which is not popular content, depending upon the learning process. And based on the and how we'll divide it based on the clustering technique and different type of clustering we have discussed that KNN clustering, DBSCAN clustering, etc. etc. Next we'll come to your mobility. So mobility of the data. Basically, it is defined by the maximum mobile station speed at which a defined quality of service can be achieved. So for high-speed vehicular mobility scenario, the user speed is basically 500 km per hour in 5G, whereas in 4G this is 350 km per hour. High mobile use cases can be supported, particularly in a dense millimeter wave deployments, where the user need to frequently hand off between the base station, and optimal identification of beamforming vector is essential. So these ML models can able to help this can able to overcome this mobility problem. Use the uplink pilot signal received at the terminal base station and learn the implicit mapping function relating to the environment setup to predict and coordinate beamforming vectors at the base station. Mobility IR network is used to design also plays an important role in the joint communication between the high mobility networks. In this case, a deep queue learning is used. In morning session also we have discussed that is called your deep queue learning, determine the set of possible connections neighboring vehicles as well as to configure the parameters of caching placement. So this deep queue learning is patented by Google. It basically performs this deep queue learning performs feature extraction, pattern recognition to identify, predict, and mitigate interference in flexible network deployments such as mobile relay nodes, etc. Now, so these are some of the applications for the wireless as well as mobile wireless communication and mobile communications. Now we'll see how this machine learning can be used on 5G, beyond 5G. So how we can use this machine learning techniques for beyond 5G. There are certain challenges. Whenever we are using machine learning techniques, it is always giving the best result, best performance. It's not always. There are certain challenges to the machine learning techniques and how to overcome these challenges. Also, that is the another area of research in case of machine learning in mobile phone communication. So there are certain challenges present in case of machine learning for 5G and beyond 5G, and some of them are critical role of data, no pre-launch theorem, hyperparameter selection, interpretability and accuracy trade-off, performance metrics, privacy and security. So these are some of the challenges which basically we are facing in case of machine learning techniques for the 5G as well as beyond 5G. And we'll discuss one by one what are these challenges. These challenges can be overcome by certain ways, by designing the network. And designing the network is people are working on that, how to design the network, which network is suitable for what kind of applications. That decision, that selection, that research is another domain to overcome all these difficulties. So critical role of data. Basically, whenever a machine learning algorithm is working, first there is two conditions are there. One is called your training, another is called your testing. Whenever training is there, we have to optimize the weights. And basically this training is performed with a labeled as well as unlabeled data.
Minutes.
So for that reason, we require a high quality data for labeling as well as means both labeled data as well as unlabeled data. But there is a scarcity of the real data set for 5G. But generally whatever the research we are doing right now, that is the simulation data. So 5G, imagine the data where to means the real labeled data, high quality data is not present, labeled as well as unlabeled. So this is a critical role. The solution for this is future engineering representation learning. that operates by feeding in all data and letting the algorithm to discover which feature have the most relevance. So that means all the data should feed into the algorithm and we have to discover which features are most relevant. Certain wireless systems have the need to update and analyze the data set simultaneously. Now, the second challenge is in case of machine learning for 5G and beyond 5G is the no pre-launch theorem. What is no pre-launch theorem? Basically, this no pre-launch theorem says average of all possible data generated distribution in every ML algorithm have the same performance when interfering in unobserved data. So basically it says that whenever you will average all the possible generated data, in case of a machine learning algorithm, it will give rise to the same performance with respect to the unobserved data. And this is known as your no pre-launch theorem. That means, in other words, I can say that all the machine learning algorithm cannot perform better or universally better than any other. That means no ML algorithm is universally better than any other. So this two statement is true for the real world applications. So the goal of the machine learning is not to seek on the best learning algorithm and need to understand the distribution types in case of 5G as well as beyond 5G applications. Because whenever we will average all the distribution of the data, it will the performance will become same with unobserved data. So you have to understand the distribution of the data in case of your 5G as well as beyond 5G applications. And machine learning algorithm has the best performance on that specific data. Next is called our hyperparameter selection. This also plays a very vital role in case of machine learning performances, in case of 5G as well as beyond 5G. So what are these parameters? Parameters is called a learning rate. Learning rate basically influences the rate of convergence. Today in morning class I have told you that in the training process we have to reduce the mean square error. The mean square error to be minimized, and this mean square error can be minimized by a process that known as your one of the process is called your stochastic gradient. In stochastic gradient, what exactly we are doing? We are minimizing the mean square error to be zero. If your learning rate will be too high, then we will come to the optimal point very fast. Maybe we may not reach that one. Maybe it will be diverge out. If your learning rate is too slow, then it will take a lot of time to train the model. So, but will reach at the optimum cases. So that means your learning rate should be optimally decided. And how will decide? There are so many algorithms are developed to decide this learning rate. So many authors have given different ideologies to decide this learning rate. Next is capacity. Basically, this capacity hyperparameter controls the degree of a polynomial. In the morning session, one of the audience asked, what is capacity? How basically this capacity helps in minimization of the error? It will basically, this parameter controls the degree of a polynomial. What is that degree of polynomial? If you are getting a higher degree polynomial, then it will fit all the sample points. If your capacity is too high, then your error between training error as well as test error gap will increase, and it will make your system to be overfit. That means your model can remember all the information. It will not, that means it will memorize the information. Then next is called distance function and density threshold. Used for cluster analysis. What is distance function? Basically, whenever your data samples or data points to be clustered, basically the cluster distance should be suitability side. How will decide it? That also another challenge. What will be the distance between the clusters? In case of k-means clustering, the main problem is that how to decide the value of k. This is again the decision value of k depends upon the environmental condition, depends upon the real data, depends upon the situations, how we are looking into, and how many values of the clusters basically we are looking. So number of trials control the learning process is another parameter. Next is called your number of layers. How many number of layers you have to choose? We are talking about deep learning algorithm, how many layers we have to choose, whether we have to go for 16 layers, 20 layers. That depends. In morning session, I have also told that different architecture, different network, deep learning network has different layers. AlexNet, VGGNet, RailNet have different number of layers, and each one is used for a particular kind of applications. One network cannot be used for all other applications. The network which is performing better for medical image cannot be performed better for wireless communication. That means we have to optimize it. We have to modify our network for a particular kind of application. How we'll do it? Number of layers, number of neurons in each layer, because each layer is having certain number of neurons. Morning session also I have discussed one of these technique that is called your dropout. We are using dropout to overcome the that is vanishing gradient. So vanishing gradient is one of the problem in case of our network training. So how to overcome this? So we have to suitably choose the number of neurons. We have to drop out some of the neurons in each layer. Next is called our batch size. Whenever your data will be too high, we cannot process all the data at the same instant. It will take some days, maybe some months to train the data. So we have to train the model by the help of a batch size, or we have to train the model by our server and just use the parameters, that is weights, for our end users. So in summary, so I can say that there are hyperparameter selection creates or plays a very vital role in case of a machine learning training, and which basically affects our performances of the machine learning. And so that reason, your customization of a machine learning algorithm, deep learning algorithm is very, very essential in case of wireless communication or beyond 5G and 5G communications. So how will customize it? So in one word, I can say the machine learning algorithm which will performing better for medical images may not perform better in case of communication, or the network which is performing better in case of wireless communication may not perform better in case of medical images. We have to look into very carefully to design this network for efficient as well as accurate applications. Next is coming to your interpretability and accuracy trade-off. The same concept of interpretability and accuracy that certain model is best suited in a particular situation, and certain algorithms are related to a given use case needs the depth of understanding of the trade-off between accuracy and interpretability. So in case of wireless communications, certain models are very accurate and certain models can able to interpret properly, high interpolate models. So if one model is having better accuracy, it doesn't necessarily say that, or we can say that it can interpret that better. So there is a trade-off. We have to see. If you look into the diagram, there are certain models like neural network, random forest, support vector machine. These are high accuracy. But if we look at our linear regressions, then classification rules, decision trees, these are high interpret values but low accuracy. So which algorithm, which network we have to choose? That is another problem, another research for 5G as well as beyond 5G communications, interpretability versus accuracy rate. Next is coming to performance metrics. Here there are performance metrics in machine learning algorithms for unseen data. There are some of the performance metrics, but this is not the thing. There are so many performance other metrics are also present. Here I have just given accuracy. So already accuracy, you know, that is percentage of samples for which the algorithm produces the correct output. And error rate, the percentage of samples for which the algorithm produces incorrect output. Average log probability is also used for density estimation on supervised learning that can give the model a continuous value score for each example. There is another that is known as your convergence speed, how fast our network model is get converged. There are also other accuracy measures, that is top 5 error. Today morning also I have discussed what is top 5 error. Top 5 error means the classification should be in the top 5. Top 1 means the classification will be among the top 1. So these are the different kind of performance metrics that are used. But based on these performance metrics, we cannot judge always the network is performing better. We have to look into certain things of our network depending upon the application, which kind of application we are using and what kind of performance metric we have to use. Next is privacy and security. This is one of the major problem, and in case of machine learning, basically these machine learning algorithms are subject to adversarial attacks. That is, an input sample can be modified to force a model to classify them in a different category for their genuine classes. That means if you will change some input samples, you will forge the data at the input end, then it will give rise to some incorrect output, incorrect result. So for that reason, the model resilience, that is robustness of the model, attribution on the input, can be achieved by the higher confidence of the input. So how to make the higher confidence and moving the decision boundaries apart to leave fewer regions of ambiguity. If we'll move the decision boundaries to the fewer regions of ambiguity, then we can achieve this. ML defensive strategy shall comprise and counterpart in the training and testing for interfacing phase, as well as the security and privacy of the database. So you have to use these techniques to make your privacy and security of the data, because your input data which is fed to the model, that can be forged and give rise to some erroneous result. That we can overcome by the help of decision boundary, proper decide of decision boundary, so that the ambiguity can be removed, higher confidence to the output. So these are the some of the challenges. Next, we will see another application of your machine learning in case of your channel state informations. In channel state information for 5G wireless communication system basically refers to the property and quality of a radio link. And this combined effect, this channel state information is the combined effect of path loss, scattering, diffraction, fading, shadowing, when the propagation signal is transmitted from the transmitter to the receiver by air. Basically, it determines the physical layer parameter. This channel state information represents the physical layer parameter. Or physical layer needs to employ low order modulation scheme when the channels are poor, and high order modulation scheme when the channels are reliable. So inaccurate channel state information leads to improper modulation scheme, which in return causes inefficient communication. In order to overcome that type of difficulty, the machine learning technique, that is machine learning based MIMO, is used for overcome this difficulty. Estimation of channel state information can be estimated by different methods: maximum likelihood least square estimation, minimum mean square estimation, square error, massive MIMO, OFDM, millimeter wave measurement is highly complex, and ML-based channel estimation to predict the channel state information in macrocellular orthogonal frequency division multiplexes. So ML-based OFDM is used. ML-based MIMO is also used.
What I have to do is I have to select my patch and my
finding the channel state information.
Patch region, and as well as I'm selecting the
so this ML makes
now I want to
more
unite
faster
them so
as well as more
both things should be
accurate.
inlined. So these are the Boolean operations what we have in the.
There is another application of this ML in case of polar as well as LDPC decoder for 5G. Basically, polar code in 5G communication is used for control plane, and low density parity code, that is LDPC code, is used for data plane in case of channel coding. 5G is basically used polar codes as well as LDPC codes. So challenge is used for a powerful decoder at the terminal site in case of 5G communication. So basically deep learning based polar LDPC code is used to overcome the problem. And you can get this detailed reference in this reference which is published in 2018, how this polar LDPC code, machine learning based polar LDPC code can overcome the problem of high powerful decoder at the terminal site. Wireless, this ML application is also used in case of wireless signal recognition. This wireless signal recognition is used most popularly in case of a military. Now people are using for military purposes as well as civilian applications. Signal reconnaissance, interpretation, anti-jamming and device identifications. This is used in case of wireless signal recognition is used. And in this case, the deep learning technique is used for signal recognitions. So wireless signal recognition is used for modulation recognition, wireless technology recognition, frequency and bandwidth estimation, symbol rate evaluation, etc. And this you can see in this paper which is published in Wireless Communication and Mobile Company in 2019, how this wireless signaling recognition is used in conjunction with machine learning to improve the performances. So this is I want to conclude here that what we have discussed in today's session as well as in afternoon session. We have discussed about learning, what is artificial neural network, what is machine learning, what is deep learning, and under this head we have discussed about convolutional neural network as well as a different kind of learning systems from supervised to unsupervised reinforcement from convolutions. And the deep neural network architecture plays a very vital role in learning process, and it just changes or increases the performance to a greater height. If we'll see the cases in case of medical as well as in the cases of wireless as well as mobile phone communications, the efficiency is increased a lot. And the application, if you will see, we have discussed the two important applications. One is semantic segmentation in medical imaging, which basically tells what is present and where is present. And if we'll see to the wireless communications, how it can overcome the difficulties. And there are some opportunities beyond 5G, how to increase the performances, how to increase the accuracy, how to design the model. And there are so many opportunities for the researchers to look into the model, to increase the accuracy, to update the weights for 5G as well as beyond 5G wireless and mobile phone communications. These are I like to thanks to the coordinators, Dr. G.A. Satish Kumar, HOD of EC Department, Dr. J. Krishna Chaitan, Associate Dean, R&D, Dr. Praveen, the faculty and staffs of Department of EC, Bardhaman College of Engineering, faculty and staff, students, audiences who are attending this, and thank to NIT Puducherry Karaikal. So these are some of the references that I have used for preparing my slides. Any questions, please? Hello.